In this video, we'll try to solve this problem from Virginia, 1992. What we have in this problem is a sequence of positive numbers where the terms are defined recursively. And what we're asked to do is to show that the sequence is an increasing sequence. And also we have to find the limit. Okay. First I guess we should try to show that it's an increasing sequence. Let's see, okay, and then how we will do that is by using induction, right? Increasing. So t of 1 is just 1, and t of 2 is square root of 2. So, well, square root of 2 is bigger than 1, so the base case holds. Well, now let's assume that this property holds for any integer less than or equal to n. Okay, and then in the inductive hypothesis, we want to show that a of n plus 1 is bigger than a of n, right? Okay. We know that a sub n is bigger than a sub n minus 1, right? And then I guess we can add 1 to both sides. And I'm just trying to convert this into some type of, like, a of n plus 1 square root of that, and then this is just a definition for a sub n plus 1, right? So just trying to get to a sub n plus 1 from this definer. And this is a sub n plus 1, and bear in mind these are all greater than 0. So a sub n plus 1 is greater than a sub n minus 1 plus 1, and these are all greater than 1. And then now I can take the square root, and then I get a sub n plus 1 is greater than a sub n minus 1 plus 1, bigger than 1, every square root of everything. And this is exactly a sub n plus 1, and this is exactly a sub n. So we have showed that this is an increasing sequence inductively. And the second thing we have to show, I guess before we even find the limit, we have to show that this sequence is bounded. Otherwise it could be like, increasing and going to infinity, right? And I don't think we call infinity a limit. I could be wrong, but first let's show that it's actually bounded. Well, I guess for now let's just assume that the limit's not infinity, right? So if it's not infinity, if the limit is finite, then I guess let's call the limit L, right? So we have a sub n squared equals to a sub n minus 1 plus 1. And then if we take the limit as n goes to infinity of this whole thing, then, okay, we're assuming that the limit of a sub n is just L, right? And then this, I guess, turns into like L squared equals to L plus 1 if you distribute the limit. We get this, and then if you solve for L, I think you get 1 plus square root of 5 over 2, and this is less than 3. Okay. For now, let's just prove that this sequence is bounded above by 3. We know it's bounded below by at least 1. So, okay, yeah, and then we'll do that using induction. Well, for a sub 1. Well, a sub 1 is just 1, so that's clearly less than 3. And then, again, like, assume that this property holds for any integer less than or equal to n. And then what we want to show, okay, yeah, we know that a sub n is less than 3. A sub n plus 1, like, I'm doing exactly the same thing as I did for the previous inductive thing. So a sub n plus 1 is less than 4. Okay, I don't know what's happening. Okay, a sub n plus 1 is less than 4. And then we take the square root, and this is exactly a sub n plus 1, and that's less than 2, and which is clearly less than 3. Okay, then now we showed that it's kind of bounded, but this argument is kind of circular. We first have to show that the series is bounded by 3, and then show that the limit is actually 1 plus square root of 5 over 2. That's what I did in the kind of the forming proof. And then this is just going through whatever I said. The first thing we showed is that the sequence is an increasing sequence by induction. I show the base case, the inductive hypothesis, and the inductive step, right? This is everything we did. And then this is, I'm trying to show it's bounded by 3. We got 3 just by speculating, I guess, up there. And then, yeah, and then this is what we just showed. And then, I guess, now we're doing it in the proper order. We show that it's actually bounded and increasing. Well, increasing sequences that are bounded have a limit. I don't know if that's something I have to prove, but that's kind of a given thing. And then, yeah, and then everything just follows from there. So the limit is just 1 plus square root of 5 over 2.